Hi everyone, welcome back. In today's video, let's look at a concept called load balancer, right? Or load balancing. Load balancer, right? So it's pretty self-explanatory, right? It is something that balances the load. So in internet, what is a load called, right? So we have our product server. Say we have a, for example, a sports streaming platform, right? So sports server, let's call it like this, right? And then now we are showing amazing content here, so everyone is super happy with their content, right? So our business gets very high, and now we are getting a lot of requests. Probably when we started it like a year ago, probably if 100 requests are coming per minute, now maybe 1 lakh requests are coming per minute. So now it becomes little bit hard for our server to handle the request. So what happens, so our responses become slow, or we won't be able to respond at all, no response, or our server might crash. If 1 lakh people instead of 100 people are trying to access your computer might get crash. So this is logical, right? So what you will do is you will obviously go for a new server, right? So we can, so you remove the concept of having one server. Now your business is amazing. So what you want to do, you want to get two computers for the same application, right? Now this is also serving sports, this is also serving sports. So now when requests coming in, so you need to understand like where to go, right? So you need to balance the load so that the single server is not getting overloaded. Say 1 lakh requests are coming in, for example, you need to give 50,000 to this and 50,000 to that, so that not one server is doing all the job and the other server is wasting its time. So for this purpose, we are introducing a device or a software in front of the servers, which is called as a load balancer. So this is going to help you to distribute traffic among your servers. So if, for example, two requests comes, it will divert one to here and one to here, right? So this is like a traffic controller, right? It diverts traffic to the right roads based on the amount of congestion that is happening. So the servers will be running the same code, and load balancer will sit in front of it and distributes the traffic to all the servers. So why do we need a load balancer? So the first thing is performance. Performance. So if you are only having one server and the number of users increased from 100 to millions or thousands, right? So your single computer will start responding slow. So here the load balancer will take it and give it to multiple servers, and then your users will be served faster. So that is performance. And the second one is availability. What do we mean by availability in internet terms is that, say for example, this goes down. For example, this computer got corrupted and this is not working, right? So load balancer has a mechanism to know that, okay, this server is not there. So if 1 lakh request comes, do not send the 50,000 to here, and the 50,000 will go waste because the server cannot handle that request. So this knows it, and somehow it diverts all the 1 lakh requests to this, even though it is lower compared to having two servers, but still all the 1 lakh request will have a response, right? In this case, if you send it here, it won't be available. So instead you are diverting to the servers which are up and running. So by that you have high availability, right? Third one is scalability. Say tomorrow, instead of 1 lakh requests, 2 lakh requests are coming, and you decide to go with another server. So you take this model again away, and then, hey, I'm super happy with my users, they like my content, so I'm going to purchase 4 now to make sure that my users are happy and get served pretty fast. So you don't have to make any changes to the program itself. It will run still the same sports, same sports, same sports, same sports. So load balancer will take care of the logic. Say if 2 lakh request comes, now 50,000 goes to this, 50,000 goes to this, 50,000 goes to this, and 50,000 goes to this, right? It's cool, right? So you don't have to tell this server that, hey, after 50,000 or after 5 calls, give the next 5 to this. So all this is done by load balancer for you. So the scalability part is pretty simple. You can just add servers, and load balancer will take care that this load is distributed across, right? So now let's have, like, not go very deep into it, just understand, like, simple ways on how it distributes the load, right? So we are calculating here that 50,000, 50,000, 50,000, 50,000. So how it does, right? So let's take a few simple ways. There are a lot of strategies that go into it, based on the countries, and also if you have a server in one country and another server in another country. So a load balancer even have the idea where the request is coming from, so which country to which country's computer to divert that request. So those kind of logic and I'll go to it, but let me explain the few simple concepts. So the first one is round robin. This is a common scheduling way, which is pretty straightforward. You give the first request to one server, you give the second request to second server, you give the third request to third server, and the fourth request again to first server. It is pretty common, and everyone is equally given the load, right? It looks straightforward and pretty good, right? So let's look at the second one to see why multiple strategies are needed, like least active connections. So what do I mean by least active connections is, say your first server. So you have three servers. And the requests are coming in via load balancer, and the first user asked, let me put 3, the first user asked for a big streaming video, the entire match, not even the highlights. He asked for an entire tennis match, and so it is going to say take 5 minutes to process that request. So this computer will be working on a 5 minutes request. So the next user didn't even ask for the full match. He just wanted to know the score of the tennis match. So it will only take like 2 milliseconds. So you give back the score saying, hey, Alcaraz versus Sinner, who won? Sinner won, he won in 3 sets, what are the score? So it happens only in 2 milliseconds, right? Say, and the third server, he or she is little bit in between. They don't want the full match, not just the score. They want to have a short highlights. So this might take maybe 1 minute. See, these kind of requests are keep on happening by luck or coincidence. Every time when it comes to the round robin turn of your first server, the users are asking big videos, and when it goes to the second and third server, it is very small video. So before you know, the first server will be processing, like, for example, 5 active requests, while the second and third server might not be serving at all. 0 active request, 0 active request. So every time you go to the second and third server, and after that, even though they both are free, you still go to the first server if it is a round robin. So in order to avoid this, they check something called least active connections. So in this case, 2 and third server are free compared to the first. So when the fourth request comes in, you don't go to it again, because you know there are 5 active requests going on. So you go to the second or the third server. Makes sense, right? The third one is hashing, or IP hashing, which is usually more common. Say, for example, you are having a dedicated session with the user. So have you seen websites like bank or something? So you log in, and after some time they push you out to ask you to log in again, saying that the session is expired. So in that case, in certain similar cases, there is some data related to that user stored on the particular server. For example, a user is logged into a bank user. This bank's computer is serving that request, right? This bank's computer is sending back its his or her account balance, and what are the transactions they have made, and all those things. So in certain use cases, this server will store certain session information. In this particular session, what and all the user has done or needed, to make sure that they see all the required information fast and everything. So in this case, when the user again calls some other request to your application, so instead of diverting it into a new server and again establishing the same set of information on the server side, it is easier to send the request to the same computer, so that it has certain information to make the processing faster. So in order to achieve that, they do something called IP hash. So we know that from the IP video or internet works video, that every computer has a logical unique address, which is called IP, or internet protocol address, right? So it looks something like this: 200 point, so some digit 5, for example. So what they do is, when a computer sends a request to your computer, you will get that IP. So you will pass this into a algorithm, say like a mathematical function, and then what you will get is like a big number. So let's not go into the algorithm, some mathematical function. So it will give you some number like 94756, for example. And once you get it, you do a mod by the number of servers. Say you have 3 servers here, so you do mod 3. So it will give you one of those numbers, either 0 or 1 or 2, right? So if it is 0, you put the request to the first server. If it is 1, you put the request to the second server. If it is 2, you put the request to the third server. So every time the IP is going to be the same, every time the mathematical function is going to be the same. So you will get the same number. If you do mod 3, you will get the same number. So with this, you will be able to route the request from the same user to the same server, so that you can make use of the session info in the server. So these 3 are like simple ways to design the strategy for your load balancer to route the traffic. So another important thing I would like to mention here is, so we saw in the availability that if one server is down, load balancer knows it and sends it to the other two servers. So in order to achieve that, load balancer will keep on pinging or looking out for your servers to see if they are healthy, up and running. So that concept is called health monitoring or health check. This is a very common concept which is used in computer science. Whenever you want to know if you are dependent on a particular service, here the load balancer is dependent on a server. So whenever you are dependent on a service, you need to know the health of that, so that you can take decisions accordingly. Here, if the load balancer knows the health of the server, it can route the request accordingly. So this is called as health monitoring. You are monitoring the health of your dependent services. Yeah, so these are the major things about health monitoring and load balancer. Yeah, let me know if you have any questions, and let's meet in another video. Thank you. Bye.